You think our sun is massive. You are completely wrong. In the true scale of the cosmos, the star that keeps us alive is nothing but microscopic dust. Let's measure it. Earth is 1. Jupiter is 11 times wider. Now place the sun next to Jupiter. The sun dwarfs it instantly. But now enter the red giants. Sirius burns 26 times larger than our sun. Arcturus 700 times larger. These are dying stars with gravity barely holding them together. Then there is UY Scuti. If this hypergiant replaced our sun, Saturn's orbit would sit inside its photosphere. It is so massive, its own gravity barely binds the gas together. Saturn would be inside it, then Jupiter, then Earth's entire orbit. The sun itself would vanish as a rounding error. UY Scuti is up to 700 times larger than our sun. But size like this is unstable. A star this massive burns fuel in weeks instead of billions of years. When it runs out, the end is violent. The core collapses. When a star this enormous dies, it doesn't go quietly. The shockwave tears through space. The explosion is a supernova so bright it outshines entire galaxies for weeks. Every hypergiant you see in the night sky is a timer ticking down to catastrophe, and we are witnessing it happen right now. The largest stars are collapsing, exploding, dying across the universe this instant. Take Betelgeuse, a red supergiant 700 times wider than our sun. Right now, it is collapsing inward. In roughly 100,000 years, it will detonate. When hypergiants run out of nuclear fuel, their cores collapse in fractions of a second. The pressure is so extreme that electrons merge with protons. Iron atoms vanish. What remains is neutron matter. 1 teaspoon weighs 6 billion tons. Somewhere in the Milky Way, a hypergiant is dying. Not in thousands of years right now, this instant, and we keep discovering bigger ones. Last year, UY Scuti was remeasured. If it replaced our sun, its surface would swallow Jupiter's orbit. But UY Scuti is not the largest. Stephenson 218 holds that title. Its radius is so massive that its own gravity barely holds the surface in place. If it replaced our sun, its photosphere would swallow Saturn whole, not singe it, swallow it. Stephenson 218 and UY Scuti are red hypergiants. Stars so bloated their outer layers barely hold together. The surface gravity is weaker than your grip. If you could stand on one, you would simply float away into the cosmic void, weightless and alone. UY Scuti could hold 5 billion Earths inside its volume, not orbiting it, inside it, packed solid. If every human who ever lived climbs through the star's interior, they would dissolve into plasma before reaching even the halfway point to the core. The surface boils at 3,000 degrees. Our sun reaches 10,000. Yet UY Scuti floods the solar system with more light than every object combined. By mass, 17 times heavier than our sun. All that weight compresses inward. Gravity tears the star apart from the inside. Its outer layers barely hold on. Surface gravity is so weak, gas simply drifts away into space. Every second, this star sheds mass. Roughly 10 times our sun's material already lost to the dark. And here's the part nobody tells you. This monster is dying faster than almost any star known. Stars this size survive only a few million years. Our small, steady sun will outlive it by billions. Betelgeuse is 700 times wider than our sun. If you placed it where our sun sits, its surface would reach Jupiter's orbit. And yet, it is still not the largest. Rigel burns 120,000 times brighter than the sun. It is a blue supergiant, hotter and denser than red giants, but even more violent. It will explode within a million years. UY Scuti is 1,700 times wider than the sun. If placed in our solar system, it would consume Mercury, Venus, Earth, Mars, Jupiter, and still have room to spare. Its gravity barely holds itself together. Stephenson 218 is even larger, 2,150 times the sun's width. The light from its surface takes 30 hours to reach its outer edge. It is held together by gravity so faint, particles escape constantly into space. Stephenson 218 convects violently. Its surface churns in real time. Gravity at its outer edge barely holds the star together. If Earth entered Stephenson 218, you could fit 150 trillion Earths inside without touching its surface. The sun becomes undetectable. We are less than dust. These hypergiants burn for millions of years, then collapse. When they die, they scream. Inside a hypergiant's core, temperatures reach 1 billion degrees. Iron accumulates. Then, without warning, fusion stops. The star's own weight collapses inward at 30,000 kilometers per second. The collapse takes seconds. 1.4 solar mass is compressed into a sphere the size of a city. Electrons are forced into protons. The density becomes incomprehensible. 1 teaspoon would weigh as much as a mountain. Then it breaks. The rebound shockwave tears through the star's outer layers at 100,000 kilometers per second. In 10 seconds, the entire star becomes a thermonuclear explosion. This is the scream. What remains is unimaginable. A neutron star, the compressed corpse of a massive star, rotating 716 times per second, with gravity so strong that light bends around it. 1 gram of neutron star material would weigh 6 billion tons on Earth. That single gram would crush through the Earth's crust like a bullet through paper. A neutron star is what remains when gravity wins absolutely. But there is something even worse hiding in the dark. A black hole has infinite density. Its gravity is so powerful that not even light escapes, and we have found them weighing 21 billion times more than our sun, warping entire galaxies around them like water circling a drain. Scale stops making sense at this point. Our sun would be invisible, smaller than a pixel next to this. UY Scuti was the largest star we knew of, but the black hole at the Milky Way's center contains the mass of 4 million suns, all crushed into a single point smaller than Mercury. You exist on a rock, orbiting a star, orbiting the gravity well of a black hole that could fit inside Jupiter's storm. The cosmos is not a size ladder. It is a reminder that bigness is meaningless. Only scale is real. Here is the part nobody tells you. Stephenson 218 holds 10 billion times the sun's volume, yet its outer layers are thinner than air. It is barely holding itself together. Stars this size lose mass constantly, shedding entire Earth's worth of material into space. Their own gravity can barely contain them. They are dying in slow motion right now as you watch. And when the fuel runs out, there is no fade to black. A star this massive collapses in under 1 second, then detonates with more energy than our sun will make in 10 billion years. You just saw the biggest stars in the known universe, but you have not heard them. Dying stars make sounds that should not exist. That is the next one. It is worse.